Good morning, mathematicians. Let's take a look at today's mini lesson. And our title is Multiplying Two Fractions. And the objective here today is I will use the algorithm and visual models to solve problems that multiply two fractions. Read it with me. I will use the algorithm and visual models to solve problems that multiply two fractions. Now, if you haven't heard this term algorithm, or as I will often refer to it as, we'll include the word standard algorithm. This means essentially an expression, a step-by-step way of solving. That's typically the standard algorithm. This is also the way most adults have been taught math. So we'll be looking at that method, but we're really going to focus in on visual models because this will help you conceptualize multiplying fractions. It will also help you understand it, and you're definitely going to see these visual models. So let's not just crutch onto the standard algorithm. All right, and since these are your vocab terms, I want you to see the standard algorithm is essentially our numerator times numerator, denominator times denominator gets us our product. Very simple. We're going to look at two visual models today. One will be the fraction strip model. It will look similar to this, and the area model. This one is my favorite because you can really see what it means to multiply two fractions. So let's take a look at a sample problem. Move on over to 9R. So my sample problem, 2/3 times 4/5. Standard algorithm, this is pretty easy to pull off. So just a reminder, what we're looking for is 2/3 of 4/5. So we want a fraction of this fraction. So 2 times 4, 3 times 5, that is it. That is our answer. Now, what we really need to figure out is, how does this product compare to the parts, or to our factors? So this is our answer, but I want you to see what this answer is. So if we have 8/15, we're comparing it to 2/3. Which one is bigger? Which one is smaller? 3 times 8 is 24. 15 times 2 is 30. So our factor is actually bigger. So this factor is bigger. Let's compare it to the other factor. 15 times 4, we end up with 60. 5 times 8, we end up with 40. So the other factor is also bigger. So when you're multiplying two fractions together, your product is going to be smaller. Now this can change if it's a mixed number, but fraction and fraction, it's going to be smaller. Now, even though the number 15 is bigger than 5 and bigger than 3, that means we're cutting up something into 15 tiny parts instead of 5 parts or 3 parts. And we're only going to have 8 of them, so a little over half. All right, that was our standard algorithm. Let's switch it up. Let's look at our fraction strip. We need a couple of colors for this one. And since we had determined that it was of 4/5 for the fraction strip, I want to begin with that second factor. So I've got a thing. Let's go from margin to margin, make my life easier. All right, I have one whole. And if I'm doing 2/3 of 4/5, I need to take this bar, I need to cut this bar into 5 equal parts. Do that as best I can. It's pretty close. All right. So I'm getting, let's see if this, oh, here's my highlighter. So I'm starting with 4/5, so that means highlight, 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 highlight. I've got 4/5. So 5 equal parts. Now I'm talking about 2/3. So if I use those two denominators and multiply them together, what is 3 times 5? 15. So now I need to recut this into 15, and this is how I'm going to do it. Each of these fifths that I've created, I'm going to divide it into 3 parts. So I initially start with fifths. Now I'm going to take each fifth and cut it into thirds. What I've just done is a visual model of how to get your common denominator of 15. Now, I want to go back through and I want to do, let's see, 2 out of the 3 parts. So I'm looking between here and here. So I'm literally taking 1, 2, 1, 2, 1, 2. So 2, 4, 6 of 4/5. Are we there yet? No. So 2/3, 2 out of 3, 2 out of 3, 2 out of 3, 2 out of 3, 2 out of 3. How many of them overlap? So how many of the 2/3 overlaps? So these two are shaded, so they're double shaded. These two, double shade, double shade, double shade. That one I leave alone. So how many have I double shaded? Double shaded 8 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 8 of 15. So this is our fraction strip model. We know the answer from the standard algorithm. We can visualize it using this fraction strip model. It's a little confusing. So we're getting 8 out of 15 shaded. 8 out of 15 is 8/15. All right. On to a third model. And I'm going to try to do this as neatly as possible. And again, we're talking 4/5 and 2/3. So I'm going to use my lines right here. So let's see. And this is our area model. One, two, three, four, 5. I have 5 rows. This could be columns, but I'm using the line paper to help me. So this represents my 4/5. So remember, my denominator tells me the total. So I have 1, 2, 3, 4, 5 total rows. And I'm going to come through and I'm going to highlight 4 out of 5 of them. If you have color pencils at home and you use primary colors, it's really going to stand out to you how this model can work. All right, now coming back through, I want to show my 2/3, so I need 3 columns. 1, 2, Got 3 columns. And let's see, do I have a different highlighter? I'll just do some shading. So remember, I have 3 total columns. I'm looking to shade 2 of them. I'm just going to do a diagonal shade through 2 columns. There's 1 column, that's 1/3. And now 2/3. What I'm going to do is I'm going to count out the pieces that are overlapping. So I've got 1, 2, 3, 4, 5, 6, 7, 8 overlapping pieces out of a total of 5 times 3 is 15. So our 8 is overlapping shaded area. So if we have 2/3 of 4/5, we're only taking this chunk as our product. So this double shaded area becomes the answer. This is my favorite visual model because you can actually see it. You can count it pop out. For the fraction strip, it can get a little abstract, but you can still see it. This one will always work for you. All right, guys. I hope that clarifies some items for you. You'll be seeing more problems like this in Prodigy today. Best of luck.